Hey everyone, it's Andrew Brown from the Free GenAI Bootcamp, bringing you another lesson. And this time, I have my friend Marko here, who's going to show you some architecting. And this is something that I really want everybody to see because when we did pre-week, we're talking about like how conceptual your concept has to be. And I feel that Marko has a really, really good use case here. But I'm going to pass it over so Marko can introduce himself.
Thanks, Andrew. Yeah, I'm Marko. So I'm a senior technical trainer at AWS. I'm here in my personal capacity as somebody who's worked with GenAI, not representing AWS. Just want to make that really clear. And today I'm going to show you a little bit of a demo of what happens when you're doing your chicken scratch, when you're talking about a project, when you're brainstorming, what it looks like. And I have a couple of I grabbed a couple of images off of a conversation I had with a project team that is completely just my personal project side of things, and we were trying to build some kind of specific voice into the AI so that it would talk in a specific manner. You can think about it when you ask an AI question, it got you a lot of data, a lot of lists. They love lists, they love facts. But when you talk to somebody like your coach, right? You got your sports coach. Does he give you lists? Does he give you like facts? No, he just says something in a human way. And that's what we were trying to achieve here. I'm going to call this solution Butler because that's essentially what it was designed to be, like a helpful assistant, but more human than the AI assistants are. And yeah, we've got this chicken scratch here.
Well, let's pull it up here so people can see the design. So I'm just going to switch over our screens here so we can see it. And you call it chicken scratch, but to me, for those who don't know, the Super Bowl yesterday, it literally looks like a game plan that you see the coaches draw. And I don't not know too much about football, but I know that they do these strategic guides with these different colors, and that's what it looks like to me. It looks like a strategic plan for sports, and I like it. But what are we looking at?
So we're looking at like about a 30-minute conversation about how the current system works. If I just mouse over it, we've got a user asking a question. We're using Bedrock here. This is just the AWS component that we're using in this scenario, hence BR. Everything else is sort of kind of designed on a off cloud platform. So technically, it could be an app on your phone that just calls up Bedrock. Then Bedrock calls up a model, and then there's a big prompt that is passed into that model. So you got the voice that defines how that model needs to respond, like that coach or butler or whatever voice you want to have it. You got all the limits, like, hey, you can't discuss these certain things. Or you've got like, oh, this is how long I want the response to be. Like a token limit is in there saying, we want to respond within like 150 tokens.
Okay.
You got all the no-nos. Like technically no-nos, like don't swear, don't be mean to people, don't do anything that would typically piss people off, right? You want to be a nice butler. We're calling it butler for all intents and purposes here. And then there's guardrails inside of the prompt. There's guardrails like basically built into the prompt. Not just like no-nos, but like guardrails, like it makes sure to not produce something that's licensed, or something that's an original work, or take information from sources, which to me that's too much. That was my like last line. Like, we're putting so much in the prompt. The prompts were thousands of tokens. So think about it. Like you're querying, you're paying per token, and you're making this huge big prompt, and you're paying for thousands of tokens. The real problem was the first response. The first response was okay. The first response was always okay. But then as soon as the interaction went on and that chat had, I don't know, maybe it's history or some kind of internal thing happening, all the other responses would start to stray away from the prompt template. the voice would break down. It would start going out of its limits. It'd start producing way many tokens that we put in the limits and all this kind of stuff. So I made a nice outline for what was happening to make it more clear. So the user would submit the question. The front end is our app. This is our app that talks to the user, and then the app just forwards that question with the prompt template to Bedrock. Bedrock calls up the model with this huge template, and then the model responds. First one's okay. The next one, I don't know what happens. The prompt template goes in. There's probably some history because they were using the chat API.
Okay.
Not like the unique prompting. There's some memory going on, right? You have to have memory of what the person asked. So maybe the history is being also passed in, the memory is also passed in, and then the second response or the third response or one of those responses is not in the voice. It's bad. It's got way too many tokens. Start producing lists again. This was the biggest crux was like, and this, I can say the model. The model was Claude. It was Claude 3 Sonnet.
Okay.
It loves doing lists. Whatever you ask it, it's going to go like, oh yeah, number 1, number 2, number 3. What were the reasons for this? So the reasons for this, it could be summarizing already on the first try because we're inputting such a big template. We're trying to prompt engineer our way to a thing that doesn't really work with prompt engineering. We were kind of thinking too many input tokens, but that's unlikely. The Claude 3 Sonnet had 200,000 token limits, so you can feed it real big documents. But what I suspect is happening is that the model internally starts summarizing all of those huge inputs, like pieces of data. And then once it summarizes what was in the prompt template, it starts losing all the voice information about the limits information and other stuff. It never really got like no-nos or stuff. And then it feels like it has an affinity for its main core instruction, where its affinity is for the assistant voice. And we kind of with a prompt template, it was really hard to get it to consistently respond like a butler that it should.
Oh, interesting. So I mean, when we're looking at and maybe it was just at the time when you built this, but Amazon Bedrock now has some guardrails feature built in. So the reason you have it in the prompt, was it because you're trying to keep it simple, or now that functionality has emerged and you can use it, or the guardrails you want aren't the same guardrails that those other ones are protecting, or you just wanted to give it a go and see what it did?
Yeah, so this was pre the features that were introduced like at reInvent. So this was probably like July, August of last year.
Okay.
And guardrails weren't a feature yet.
I
This
don't
isn't
know,
released.
or if it was, then maybe the feature was less. I don't remember when the list it is, but
It might have been in preview, but this was like not even considered by the project team.
I see.
And I wasn't the designer. So I was there as an SME. This is a buddy of mine essentially building this, brought me in as an SME to just see why this is a problem.
I see. So working within the confines of the existing design. Understood.
Yeah. So I'm working with an existing design that somebody came up with. I don't even know who came up with it. I don't know why they put the guardrails into the prompt template. I would never do that. And yeah, probably at this point that the product is evolving and it's kind of almost ready for market. I haven't kept in touch. Proposing a solution that actually worked didn't go well with some people.
Oh, okay.
Yeah. So but I would say guardrails definitely don't belong into prompt engineering. I would say even like you could do limits differently. You could do limits with the prompt with the settings for the model itself, right?
Okay.
Max token. So you use max token. You don't put like, give me the response in 40 words or less. You can put an output indicator in the prompt, but I'd probably say, hey, again, that's going to get lost over time.
So what we're looking at is basically a snapshot of this project at a particular place in time, and then it has continued on. So you're not you don't know like what they've overcome, but we're talking about exactly what was the technical outcome at this stage of the project at this level of configuration. I got it.
Yeah.
Okay.
Yeah. So this is not released. It's not a public product yet. It's still kind of in development. This was, let's say, the second iteration of the product.
Okay.
This was very quickly after, let's say it started very quickly after Claude was released, and Claude version 3 Sonnet. And when Sonnet was released, this was actually financially possible because it was much cheaper per token on Bedrock, because they don't have infrastructure of their own. So they were either like, okay, are we going to use OpenAI? Are we going to use Bedrock? Are we going to use something? And everything was extremely expensive at that point in time.
That
So
makes
when
sense.
Claude 3 was released, the pricing per token went down significantly. And that was like the iteration where they started like really ramping on it and really driving the development forward. And that's where they found these problems where, oh, it's responding well on the first try. And their testing was designed where, at that point, where it's like one prompt, oh, it looks good. One prompt looks good. One prompt looks good. But then somebody went and said, hey, how about I chat with it, see how it does in a real world scenario, and then found that the second or third response or some subsequent response would break away from the template, from the prompt engineering that they did.
There's a I don't, if this was developed last year in the summer, this probably didn't exist either. But at the time, there's a feature called like it's evaluations, and so it sounds like your team was manually testing it, and now there's obviously the way of like giving a huge list and developing it and inputting it. But was this like a manual testing process?
No, it was part of the release pipeline. So when the release pipeline ran, it ran like, let's say, 50 instances that would just each issue one specific prompt, where they
Okay,
could then where they can then gauge the response. This was manually built,
I see.
but it ran inside of a pipeline. It wasn't a product itself. It was built into the pipeline of the front end itself.
But there was evaluations. It was just a manually configured
It would
pipeline for evaluations.
their own pipeline, like evaluations, essentially.
Okay.
Yeah.
So I guess for boot campers that are watching, that something that you might want to consider is including how you test it as well. Like when you're making a project, like these are kind of like the I wouldn't say hidden work, but I guess it is hidden work, but it's like additional work you wouldn't think to normally architect, because this is really the meat of what the thing is. But these other workloads, for boot campers that are listening, you might also want to consider testing that, because that's also kind of interesting process as well. If you were to build this today, is there any specific things that you might change?
Oh yeah.
Well, I guess, and also, it wasn't your architecture; it was someone else's, and you're working the constraint. So,
Yeah,
uh, and not to dig at this architecture, it is what it is. It's a makes sense for its time, right? And the knowledge base of that team. But what would you do differently if you could?
well, let's move on to my proposal. Let's move on to my proposal. So this is in the same essentially call that we were doing. I just moved out all of the other things of how it's built right now.
Yep.
And I said, so what you want to do is add some logic that will actually maintain the chat,
Okay.
and you don't use Bedrock's chat interface. And that was number one. That was like strike one for me, saying,
Is
hey,
that to give agent logic?
so the idea here with this logic is to just remove all the memory, remove all the actual chat memory into their own logic. You
Okay.
could use something like LangChain as a framework and use memory in the LangChain instead of depending on the memory of the chat mode on Bedrock
Okay.
of the model,
Okay.
right? Because you have two unknowns here. You've got an unknown of how Bedrock handles memory, how much memory is assigned to your session, and how the model summarizes anything you've put into that chat history. So these are kind of out of your control when you're just depending on the service itself.
I see. It's interesting because I've done a lot with Amazon Bedrock, but I can't tell you how much it holds and what it does. And I probably know at some point, but this is more of a note for people that are like having uncertainty. Like, doesn't matter how much I use a tool, I still have uncertainty always. And I go, is that how it works? Is that how it works? And so I'm always saying, I always use the words "I think" as opposed to like with certainty because I've always there's always a chance that I could be wrong. So that's kind of interesting. But sorry, yes.
Yeah, the idea here is it's a service. And like
Mhm.
any other service, you don't control any of those settings, or at that point, or at like even at this point, you don't have full control over how the memory is handled, how quickly it started summarizing, and such and such things, right? So
Yep.
this kind of looks very, very confusing, but basically it's your first response goes to a model.
Okay.
We'll talk about this later. Then you get the response back to the logic.
Okay.
Then you go to you through Bedrock, you go to an agent that actually evaluates that response
Okay.
against an index to validate whether that is correct. It's just
Mhm.
you've got the embedding of the response and the embedding of the index, and you see the similarity, how close they are, and if it's above a certain threshold, you can say, yeah, this is correct. This
Okay.
is to avoid hallucinations. This is to avoid something that is incorrect, because we wanted fairly correct answers there. And then number three was feed that response once it was evaluated with the agent back to another model, or an even smaller model that just summarizes.
Oh, that's what that is. Okay, it's a
Yeah,
summary model. Okay.
it's a summary model, and then this one implements the voice. This model actually implements the voice and responds in that Butler voice.
The marking on the summarization, what does that represent? Is that a specific represent like it says N2 or H2 there above it, like in the
M2,
bubble?
yeah, model two, model one,
Oh,
model two.
oh, I see. M. Okay, model one, model two. That makes sense.
It'll be clearer when I make this uh, proposed graphic.
Ah, okay.
So the benefits of this design is response is always generated from lists, facts, whatever we have. You've got chain history in your logic, which we'll see. Avoid any unknown behavior. You got a smaller token input because you're not passing that huge template. You got externalized guardrails, externalized token similarity, and affinity to the Butler voice with a tuned model, right? So basically, at the front end, you implement logic of how these responses are handled. In the logic, you implement the memory. For each interaction, for each session, you keep memory here. And then instead of invoking one model in a chat with the chat API, you just invoke it with a text API.
Okay.
You send in the initial text, and the prompt is just a question. It doesn't have anything. You feed the response to the model. The model uses an engine agent to do evaluation, to do guardrails. Again, guardrails weren't implemented at that point in time in Bedrock.
Mm-hmm.
And these guardrails, you could implement them in Bedrock as is. I think it would be more effective than writing your own agent to talk to an index to figure out whether you're guardrailing, you're evaluating, you're valid, etc.
Mm-hmm.
If the response is good, then we say, yeah, model response with a full response, all the full list, all the facts, the huge chunk of data. Now, we've avoided sending a big input, but we're getting a big output. Here you can do max tokens. Here you can, again, regulate it with the settings of the model instead of prompt engineering your way to a certain size or type of response. If, of course, this fails, you've got a canned response. And the canned response goes out to the user and says, hey, I'm sorry, I can't help you with that. Or can you ask a question a little differently, or something similar? And we're doing this every time, even if there's facts that are in there that are correct. We're assuming that if it's below a similarity of the whatever was indexed, we're assuming that it's wrong, because you'd rather go and do a canned response than risk any kind of hallucination. And you can do this threshold at any similarity level you want, right? You could say, I want 95% similarity, or you want to have like 80% similarity. And that's perfectly tunable. And the less similarity you allow, the more creativity the model will have. The more creativity the model has, the more potential hallucinations there are. And hallucinations were a big thing back then, right? That was kind of the major problem, was like the model would hallucinate an answer, hallucinate a link, a reference link in some documentation. You'd click on that link and it'd be like 404. This doesn't exist. What are you talking about? Right? Because it actually would like generate a URL that doesn't exist It didn't have like an agent that pulls that URL and checks it. So this is the thing that is like now evaluating the model and seeing whether it works. So we got this full response. This full response now goes to the logic, and the logic then records this in memory and then sends it back with the prompt template, with the voice structure, maybe tokens, whatever you want to put in that template. And that template is going to be much, much smaller now. And then I propose that for the voice itself, we use a tuned model that takes you don't even go with Claude anymore. You just choose another model that you can tune that will have a voice that you want to have. Because Claude at that point wasn't tunable. Claude 3 Sonnet wasn't tunable at all. You'd have to like reach out to Anthropic and say, hey, I want to change the voice of the model. And they'd be like, yep, bring the dollars, dollars, dollars. And we didn't want that. We wanted to pick a very simple model that could just summarize the facts that were generated from the original model that was intended to do this, and then tune that model to a specific voice. And then that response would always be in that specific voice. That's the main idea here. Now, additionally, we discussed that there's potential for retrieval augmented generation for the model itself, that we would actually put like facts into a knowledge base and then improve the reliability of the model. This was kind of like an additional discussion. Do we need it? Do we not need it? Is general knowledge of the default model enough for it to respond? I think it might have been, but RAG is an option where you have a model that the general knowledge doesn't really allow it to answer the question accurately. And if you want to increase your accuracy, you put all of that stuff into your retrieval augmented generation, into a knowledge base. And then again, you can connect that knowledge base. Bedrock has it now. Well, it had it back then already, knowledge bases and agents, where knowledge bases are just basically these lists of things that it needs to know. And your agents are programmatic ways of accessing other components. You can do RAG through an agent as well, where you like use an agent to connect to like a SQL database, run some SQL code, get some SQL results, and then perform some types of activities like that. But the idea of the actual retrieval augmented generation here was to increase its accuracy on the first response already before validating it with the agent. And if that works well, we might actually say, hey, we're not even going to evaluate with the agent itself, because we feel that by using retrieval augmented generation, we get accurate answers already. Again, those you can use both, you can use one. That was kind of the end of the discussion itself at that point.
Cool. Well, I mean, it looks like we have all the most common moving parts in here, and evaluations and guardrails. So yeah, this looks like a very complete example as a baseline for folks to start modifying or looking at. I like how I was like, yeah, evaluations, and it makes it into the later diagram. So clearly, there was a lot of thought put into that. I don't think I have any questions. I mean, it's like this is a perfect illustration for boot campers to pick up on and to work with. Any final thoughts or words for our boot campers?
Yeah, I mean, when you're building your solution, you're probably going to try with prompt engineering because it's the simplest. But prompt engineering is going to only get you to a certain point. When prompt engineering doesn't improve your results, you need to start considering retrieval augmented. You need to start talking about agents. You need to start doing like, this is essentially a chain of thought with two models, because we're feeding the question to the model, then we're putting it back into the logic, and then the logic sends it back to the tuned model, and then the response goes through the logic. You could do additional validation of the actual end response in here in the logic if you wanted to, but it just follows the same diagram, so I didn't add more diagramming here. The idea here is that this logic does like a chain of thought type of scenario, but with two models.
Okay.
Yeah. Typically, a chain of thought, you'd implement it as like, say to the model, say, hey, think about your response and then evaluate whether it's good, and then the model self-evaluates, runs a chain of thought itself. You can see that in DeepSeek. If you run DeepSeek, you see how like it's creating like thoughts and then evaluating each other and thinking about what it needs to say, and then gives you a response at the end. This is just externalized from the model itself. And you have full control in the logic. Yeah, it's more effort. It's more effort, but
again, you whatever you wanted to do, you can do. And a lot of the apps that are being built out here, that are talking about agents, they're building their own custom logic for reasoning, and a lot of times they're using Claude underneath, and it's the results are like incredible.
yeah.
So I mean, it's interesting DeepSeek's approach, but it's not necessary. It's just a different way of doing things. But sorry, yep.
Yeah. I mean, you can do it. You can, slice a piece of bread many different directions, right? So this is the thing. If you want to build something that's unique, if you want to build something that's going to have added value, um, don't consider that building your own logic is out of the question. Building your own logic can, add a lot of value to your product. It's hard. It's not easy. It's a huge undertaking, building your own logic. But sometimes you got to do the hard things to succeed, because everybody else can use the built-in chain of thought. Everybody else can use, can spin up, use Olama, spin up your DeepSeek, get the chain of thought, and bada bing, bada boom, it works. Here, you're doing something that if you want to market it as a product, it needs to be unique. And that's the important part of these things. We don't really know what's possible with generative AI, with AI in general. Just like in the 60s, they had computers. They didn't know we're going to play Minecraft on them. They didn't build computers to play Minecraft. It's a discovery process. And we're in this discovery process. And these are exciting times. So if you have to build some externalized logic, what you can also do is when the better models come along, you can just swap out this model. You got your own logic already. So you're future proofing your application. This is your app. This isn't your app. This isn't your app. Your app is in here. It's your front end. It's your logic. It's your invention, essentially. It's your innovation.
The first neural network that was built back in the 1950s or 60s, I don't remember. I covered it in my GenAI Essentials course, but like you'll see, and it's like a big mess of cables, and the only thing it did was it was like calculating numbers for some kind of surveying utility, like for people measuring distances. It's like all that work just to calculate some numbers.
Yeah.
I'm sure they didn't see this coming.
I think it was the Perceptatron that was the first one that was able to detect images or light coming into it, and it had like a grid of 40 by 40 light detecting diodes.
So it sounds like you would pass my GenAI Essentials course, because that is the exact thing that that we're talking about, is this Perceptatron.
There you go.
So yeah, but yeah, it's just wild to see that thing and to see what it can do. But like the fact that they could build it like so long ago, and yeah, there's a lot of opportunity here. We don't know, where the moat is to be built, and or what AI is going to eat in terms of our lunch in the future. But it's still really exciting, and obviously, what the stuff you put in front of your model, it's not only the prompt document, but the agent logic is really like is where I think where the I don't like using the word secret sauce, but like it is the special ingredient to your application. um but yeah, I want to thank Marko for coming out here and walking us through this diagram, like series of diagrams. And yeah, I hope everyone learned something really great here, and we will see you in class soon. Ciao ciao.
Bye.